Hello students and viewers at home. My name is Mrs. Emeanua Chioma from Physics Department, St. Charles College, Onitsha. My topic today is fluids at rest and in motion. The specific objectives for the lesson. By the end of the lesson, the students will be able to 1. Define surface tension. State the effects and ways of reducing surface tension. 3. Define capillarity. 4. List the applications of capillarity. Fluids at rest and in motion. The molecules of liquids and gases are more free to move than those of solids. Therefore, both liquid and gases are free to flow. For this reason, liquid and gases are grouped as fluids. Fluids have no rigid shape, and they respond to forces more frequently than solids. For fluids at rest, we have a type of force which acts on the surface of the liquid. This force is called surface tension. Then for fluids in motion, we have another type of force which exists between the layers of the liquid. This force is called viscosity or viscous force. Surface tension. Surface tension is defined as a tangential force acting per unit length on the surface at right angle to one side of a line drawn on the liquid surface. Or, it is the property of a liquid that makes it behave as if its surface is covered with an elastic skin. We say that surface tension is that property of a liquid that makes the liquid surface to behave as if it is covered by an elastic skin. That is why insects can perch on the surface of liquid without sinking, because the liquid surface looks as if it is a skin, a hard skin. That is why insects like pond skaters, butterflies, flies can comfortably stand on the liquid surface and drink water without sinking. That is why if you keep 2 buckets of water close to you and carefully observe the 2 buckets, one with soap or detergent inside it and one that has a clean water inside it, you will notice that insects will be perching on that one with clean water inside it comfortably without sinking. But when you observe the one with soapy water, you will notice that a lot of insects have died on the surface. Those dead insects, the insects die while perching on the liquid surface because the surface film has been broken by the detergent or soap. That is why when insects perch on that soapy water to drink water from there, they get stuck. But the one with clean water, you will notice that there is nothing like a dead insect on top of it. That is because the surface tension is still intact. So insects can comfortably perch and drink water from it. Surface tension is due to the attraction of surface molecules by those below them. For this reason, or due to surface tension, drop of liquid assume spherical shapes. When you open your tap to get water or when you close your tap, the last drops of water that comes out it comes out in balls. That is because of surface tension. Surface tension is represented by a Greek letter gamma, and it is expressed mathematically as force all over 2 times the length. The length is 2 times because we said one side of the line, it has to go one and come back. The SI unit of surface tension is Newton per meter. Application of surface tension. 1 is waterproof materials. Waterproof materials is one of the applications of surface tension. These waterproof materials are materials used in making raincoats, used in making umbrellas, and also used in making tents. These waterproof materials have what is called surface film. They develop a surface film when water is falling on them. This surface film can only be broken when the body of the material is scratched with a finger. That is why when you have an umbrella over your head, if you use your finger to scratch the inside of the umbrella, you will notice that water will start dripping down and start touching you. That is because the surface film has been broken. The same thing applies to raincoats. When you are wearing a raincoat, if you use your finger to scratch the inside of the raincoat, you will notice that the surface film has been broken and you start getting wet immediately. The same thing applies to people living in tents. People living in tents do not use their finger to scratch the inside of the tent. If the finger is used to scratch the inside of the tent, you will notice that the surface film will be broken and water will start dripping. Another application or another effect of surface tension is cleansing action of soap and detergents. Cleansing action of soap and detergents. When oil is made on a plate, the oil can be there for a long time except when soapy water is spilled or when soap is added to that oil. So if the soap is added to the oily plate, the surface film will be broken and the surface tension is destroyed. Another effect of surface tension, how we can observe that, is by gently placing a needle on top of water that is so much at rest. When a needle is gently placed on it, you will notice that the needle will remain afloat if the surface film is not if the surface of the water is not disturbed. Ways of reducing surface tension. One way of reducing surface tension is by addition of alcohol. Impurities like alcohol, detergents or soap, oil or camphor. All these are the same thing. They can reduce the surface tension when they are added to a liquid, and all of them are classified as impurities. We can use addition of these impurities to water to control the breeding of mosquitoes in our environment. How do we do this? We can do this by coating the water in our gutters by adding water or by adding oil to the water in our gutters, or by adding camphor, or by adding soap, or by adding alcohol to water around our environment. This will destroy the surface film of those water in the gutters. We know that mosquitoes lay eggs on the surface of water. But when the surface film is destroyed, the eggs or the larvae of these developing mosquitoes will sink. But if the surface film is not disturbed, these mosquitoes can mature when their eggs are laid on the surface of water. So, to control the breeding of mosquitoes in our environment, we can sprinkle some oil on top of water in our gutters. Another way of reducing surface tension is by heating the water or increasing the temperature of water. When you heat water or increase the temperature of the liquid, the surface film is destroyed. And when the surface film is destroyed, the surface tension is reduced. Capillarity. Capillarity is the tendency of liquid to rise or fall in a narrow tube. Such liquid that rises some distance on this tube depends on the following factors. One is surface tension. Two is cross-sectional area of the tube. The narrower the tube, the greater the rise of liquid in it. Terms used in explaining capillary action. We have two terms that we can use to explain capillary action. One is cohesion. The second one is adhesion. Cohesion. Cohesion is the force of attraction between molecules of the same kind, like molecules of water, molecules of hydrogen, molecules of oxygen. The force of attraction existing between molecules of the same kind is what is referred to as cohesion. Then we have adhesion. Adhesion is the force of attraction between molecules of different kinds. For example, molecules of water and glass, molecules of different substances. The force of attraction existing between those molecules of different substance is what is called adhesive force. Cohesion and adhesion explain the different action of mercury and water when spilled on a clean glass surface. Why water wets glass? Yes, water wet glass because the force of adhesion between water and glass is greater than the force of cohesion between water molecules. Therefore, water spreads out on a clean glass surface when sprinkled on it and wet glass. After drinking water with a glass, you will notice that there are still some water on the glass. That is because of this force of coadhesion. The force of adhesion between water and glass is greater than the force of cohesion between water molecules. Therefore, when water is poured into the glass, you cannot remove all the water. Some will still stick to the glass. Why mercury do not wet glass? Mercury is the only liquid metal we have. And when mercury is spilled on a surface, when mercury is spilled on a hard surface, mercury forms spherical droplets or spherical globes on that surface. Why? And none of the mercury will remain on that surface. That is because of force of cohesion between mercury molecules. This force is very, very strong, holding the mercury molecules together. So when it is spilled on a surface, it forms droplets instead of wetting the surface. The force of cohesion between mercury molecules is very great. This force of cohesion, adhesion, and surface tension are responsible for the capillarity of liquids. Applications of capillarity. Absorption of ink by blotting papers. When we write on our paper with a pen, we see the ink on the paper. You notice that our pen has a pointed end. Rise of water in stem of a plant is due to capillary action. If there is no capillary action between the water and the root of the plant, the plant cannot get water from the ground. Rise of liquid wax up the candle. Rise of kerosene up the wick of lantern. Have you ever asked yourself, why is it that when I light my lantern, immediately you see the light? That is because the threads of the wick has tiny capillaries. And when it is dipped inside the kerosene, it absorbs this liquid. It absorbs kerosene and rises up the wick. Use of damp-proof scores, DPC, in building and road construction. The damp-proof course, when we are doing the foundation, we will notice that after pouring your sand mixture, the engineer will use a stick to continue to dress that until there is some liquid will come up. When this liquid comes up, it shows a good mixture of that cement and sand. Rise of blood in capillaries. These are all applications and more of capillarity. Shape of water and mercury in capillary tube. When a capillary tube is dipped inside container of water and mercury, if it is inside container of water, it forms a concave meniscus. But when it is inside a container of mercury, it forms a convex meniscus, making an angle between the liquid inside the tube and the capillary tube. This angle is what is called the angle of contact. Then let's look at evaluative questions for this lesson. 1. Define surface tension. 2. List the effects of surface tension and ways of reducing surface tension. 3. Define capillarity. 4. List 5 applications of capillarity. Students, when you answer these questions, you can reach me through my WhatsApp number 080-233-54594. Thank you and stay safe.